The merge on write pattern. This is the inverse pattern to the copy on write pattern. This is not an anti-pattern. This is the inverse. So all the conditions here are the same as in copy on write. Given this, we have some physical memory partitioned into units. Let's assume blocks for the moment, but it doesn't have to be blocks. We have allocate, write, and update operations on those units. And then the solution is you hide physical addresses. So like in logical block addressing, you make users share the data without them even noticing, so it's really the same as in copy on write. However, then there's a difference, and that is you deduplicate physically only at write and update time. Deduplicate means you do the inverse operation of duplicating. What copy on write does, it duplicates the physical blocks. So again, our example, we had logical numbering and physical numbering. Logical numbers 42 and 43, and they pointed to the same physical block, let's say 9. And only if you change that in copy on write, if one of the users, if you change block number 43, then you have to do a physical copy. So then you have something like 42 maps to 9 and 43 maps to 7. That's copy on write. What MOW does, merge on write, is just the opposite direction. It's the inverse, which means if you change one of the blocks and then you find out, well, after the change, the physical contents of those blocks are the same, then it's fine to keep just one of the physical blocks. Then you can redirect the logical numbers to this one physical copy. It's just the inverse of cow, of copy and write. That's merge on write. So advantages are similar to cow. Again, it saves considerable storage space, you have asset properties, you have the same drawbacks, you have the managing overheads, and you may have fragmentation, blah, 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 blah. So this is all the same as in copy on write, nothing new. Just some other use cases that are maybe not immediately obvious, but they are advertised by some companies as being super outrageous, even though once you understand copy on write, merge on write is really straightforward. That is deduplication. So assume you have a file system where you store files in different versions over and over again. And in this kind of situation, you can save a lot of space by only saving the physical blocks once, even though those physical blocks are referred to logically multiple times. So you could also say this is a variant of compression. Yeah? This is super related to what compression does. And later on, we will look at different compression techniques. One of them is called dictionary compression. Dictionary compression. And this is something very similar to what we have here. We have symbols, logical symbols pointing to physical pages, and that's a similar idea that's done in dictionary compression. We will get back to that. But let's do an example, again with shadow paging. If you remember my video on shadow paging, we were in this situation. So what happened here, we changed logical block number 3. We changed it, and as we changed it, and we are not allowed to change physical block number 5, we had to make a copy. So that's what happened here. Physical block number 6 represents the new version, a changed version of physical block number 5. So we had to put it to a different place to have both versions at the same time. So what happens in shadow storage if you change another block, let's say logical block number 1, then again you have to make a copy. So logical block number 1 points to physical block number 3, so we have to copy it somewhere. Let's say physical block number 1. So this physical block number 1 now represents the new version of physical block number 3. That is what shadow storage is about. But what happens if this changes physical block number 3 in a way such that the physical contents of block number 1 are equal to the physical contents of block number 6? Those blocks represent the same data. Why do you keep a second copy? That is what merge on write is about. In this situation, you should detect that actually you could do something like that. That's a much better option. Here, you have those two arrows pointing to the same physical block. So there's no need to keep a copy. Of course, if one of the logical blocks 1 and 3 is changed again, then you have to do the other copy. But as long as it is the same physical contents, you can make them point to the same physical block. That is what merge on write is about. It's the inverse of copy on write. In the lab and in the exercises, we will look at how that is implemented efficiently. It boils down to keeping checksums for the different blocks, but you will see that in the lab. If you liked this video, don't forget to hit the like button. Thank you. So if you want to see more database videos, be it in English or in German, take a look at my website datenbankenlernen.de. It has a couple of English and German videos. You can also subscribe to my YouTube channel, Jens Ditt, or you look at our website, infosys.uni-saarland.de. See you there!